Hey guys, so welcome back. Let's go for the first full power up of this radio. This is a tube type car radio from a 1953 Chevrolet, a Chevy 210, which is similar to a Bel Air and the 150s. Anyway, so this was sent to me by a friend of a friend, and we did, in part one, we did some checking out of the transformer, the power supply that's in here. We checked out to make sure the transformer was okay. It has a vibrator in there that's used to boost the 6 volts DC from the car to hundreds of volts of AC, and that was really interesting to see how that works. So if you missed that, you might want to go back and watch, episode 1. It's really very interesting. I'll put a link to that in the show notes, or you can go to the playlist, and I'll put maybe a link to the playlist up here in the corner if that works. So anyway, and as we did that test, we weren't able to put full power up to this because we couldn't put the tubes in. And the reason why is that the power supply that I was using, a lab type supply, would only put out like 3 amps of DC. And since I don't have a 6 volt car with a 6 volt car battery here, I'm having to use a power supply to supply the DC. So I had to go find another DC power supply, or so-called battery eliminator, that would have the power necessary to drive this radio with all the tubes and their filaments in here. So I had to find another power supply, and unfortunately it also needed work, so it had to be repaired and restored. So I'll put a link to that as well, because I made a video of that in the show notes, and I'll put a picture of it over here. Actually, it's right back here. It's EICO 1064. So we're going to see how that works with this radio and see if it works, and we'll drive this radio if it has enough power. And if so, we'll put the tubes in, and we'll see if this radio works, and if so, we'll see how it does, and if there's something we need to do to take care of that. So I'm doing this, like I said, for a friend of a friend. Some of the detail I have in here is primarily, for his enjoyment. This is his radio. If you find you want to go a little faster, feel free to skip ahead in any of this. But meanwhile, when we get back into this, we'll get into part 2 and find out how it goes. So let's get started. Hey guys, so welcome back. Yeah, so we said we needed a power supply solution, and we have one. There's another video that you may or may not have seen yet. I don't know if this is which one's going to come out in which order, but this is a power supply that I've fixed, and this will put out 6 volts with plenty of amps that we need to have. It also has a 12 volt setting, but I'm going to have it on 6 volts, obviously, for the 6 volt radio. Okay, so what we have is the AC coming in through the Variac isolation transformer dim bulb. That's all still in. This is plugged in to the isolation transformer, so this is isolated. Alright, and this shows the voltage coming from the Variac. Since the dim bulb's in, if I start picking up a lot of current, we may see this voltage drop. At some point where I feel comfortable that I don't have a short issue, I may go ahead and take that bypass that dim bulb, because I have a second. And I'll show that in just a second. So the voltage DC comes out of here, goes into my panel. At my panel, it then comes out and goes to a sealed beam bulb, which is out here in the back. It's back here in the back because I needed to have room for it. There it is right there. That's a 6 volt sealed beam bulb that is in series with the output of this. The current from there will come back into this panel, and I have a voltmeter hooked up here, which will show me the voltage after the dim bulb, because the dim bulb is going to take a toll of some of the voltage that's going through. So we'll see the voltage coming out of the dim bulb here. So if there's any way we can see this a little better, I don't know. It's not ideal for bench top work. I got it for completely different purposes to do with this. Anyway, so this will show the DC voltage coming out of the dim bulb. Alright, so then when it comes out of there, we're going to go into a fuse. This says it'll draw 5.5 amps, I believe is what it said. So I've put in an 8 amp fuse in here. This has a 5 amp fuse here for the line voltage, but this is 8 amp for the DC coming out. Now when it comes out of there, it's going to go first through this meter. This meter is set up as an ammeter on the 10 amp scale. So this will be reading amps. These gauges are not reliable, so we're not using them. That's why this will be telling us what this one's supposed to be telling us, and this is the ammeter, and it'll tell us what the amps are here. Okay. And as I mentioned, the dim bulb will be back there too. So, but this voltage is after the dim bulb, not out of the power supply. Okay, these are the outputs of the ammeter. You'll see this one I put yellow tape on. I wrote neg on here to remind me that that's actually, in spite of the fact that it's red, that's my negative lead, coming out of the ammeter. Okay, then the positive out of here then comes to the red lead and comes up and goes here to our power end pigtail that you see here. Okay, now over here I'm set up to start measuring voltages, test voltages within the device under test. So this will be reading our voltages as I move this probe around and test things. I currently have it set attached to chassis ground right now because most of the voltages are measured to chassis. Alright, in terms of tubes, there are no tubes installed yet. I did some tube testing in the meantime, and so, I'll show you a picture of it, but basically this is the output, or the outcome of the tests. Okay, you can see there's 6 tubes there. We've got the RF amplifier, the converter, the IF tube, the detector ABC first audio, the audio output tube, and the rectifier tubes. Okay, none of them had displayed any shorts on my tester. And as you can see, there's 3 tests for the detector. Okay, here are the test results in terms of the way that the meter shows it on my tester. I have good, I have fair, I have excellent. So what I had here is the audio output tube is reading kind of weak, but I think it's going to work. The converter tube is also a little on the lightweight side, but I think it'll also work. Everything else in here is pretty good. The detector tube looks like it's almost new. Okay, so in the meanwhile, what I've done is I've ordered a set of replacement tubes for this, and they may be here in about a week or so. When they arrive, we'll have them in case we need them. But I'm certainly going to be able to go ahead and go forward with this. The other thing I've done is I've ordered a solid state vibrator to replace the the antique vibrator that's in here. And it'll be probably another week before that comes in. But this one's working and is able to give us the ability to go forward with the testing, I think. So what I thought we would do is go in and make sure that everything works fine with this new power supply, new to me power supply. And we'll see how it all works. So I have the vibrator in, no rectifier, no other tubes. We're just going to work our way through this in a very systematic and hopefully careful way. Also, I have a 4 ohm 10 watt power resistor set up into the speaker output. Won't need it for a while yet, but I didn't want to forget it, so I've got that in there. And when we get around to getting tubes in, if we're still doing good, I've got a 4 ohm speaker we can hook up and see if we're getting anything out of the unit in terms of sound. I also will need to hook up an antenna at that point. Okay, enough of that. Let's go ahead and get into this. Okay, so we have this set up for volts DC. We have this set on amps, 10 amp scale. We have this set for voltage AC because I'm hooked up to the output of the transformer here. So I've got it set up to one of these leads to ground. Okay, one of the leads on one side of the yellow drop, orange drop to ground. Okay, so we got the AC power on. This is turned down to 0. Here comes the power. This is reading the DC out, and it's currently in millivolts. All right, here we go. So if you can see that, we're at 1.3 volts. Like I say, don't pay much attention to this. Be watching this. Okay, there is our vibrator running, and here's the output of our transformer. So far so good. We're not getting any glow on the bulb that I can see. We're pulling 350 milliamps through this line at this voltage. A little bit of a drop on the AC input, but I'm going to leave it alone for now. By the way, this is on. Okay. So what I'm going to do now is I'm going to take this down, leaving this on so I have a drain. It'll drain the capacitors in here. So now what I want to do is install the rectifier tube. 0Z4, cold cathode rectifier. Okay, let's put this in. Okay, the rectifier is in. I'm going to move my test point to be on the, where I want it to be is right here on the cathode of this. I'll be measuring to ground. And that should be, I think that says 250 volts to ground. 260, okay. Alright, so we're going to go, and keep in mind there's no load on this. So there's my cathode. Okay. Okay, this wants me to reset it. And now we want that, thank you for reminding me, that now needs to go to DC because we're looking at the output of the rectifier. Okay, you should be ready to go again. All the way down, this is on. Okay, there's 4¼ volts going in. 208 volts out of the cathode. I said 260 a little while ago. We're pulling 600 milliamps. Come up a little bit. There's 5 volts. 247 volts. 5.4 volts, call it 5.5 volts out, 274 out. Okay, so that's high enough. I'm going to turn it back down. So I had it before at this voltage when I was running on my little lab supply. So I'm going to assume that these capacitors have kind of already had whatever reforming they're going to do within reason. I don't think I'm going to need to stand here and hold it at this for much longer. So I think what I'm going to do is start putting the other tubes in. So the question is should I do them one at a time or just go for it? So what I'm thinking about doing is just going ahead and putting them all in so I don't have some running at 1 voltage but others are too high. Just go ahead and put all the load on the system, and we're going to bring it up slow anyway. And it'll take a lot less time that way as well. I don't think we're going to be too reckless because we have such control on this. Okay, so what I'm going to do is shut this down and populate the tubes. And yes, I got a new set of documents from the owner on this, which had some much better resolution on things. And one of the things that it did confirm for me is that that little disc-shaped thing down there is indeed that capacitor we're talking about, and it's got that electrolytic across here. I don't know that we need that. I don't know why it's there. I'm going to go ahead and run the unit with it on there because I guess somebody tested it that way. But one of the things that they did that I don't like is that they didn't mechanically attach the legs. They just kind of laid it in there and soldered it. So at any rate, I will disconnect that if for no other reason, just to solder it on better, wrap it around at least. And when I do that, then I can do a test to see, hey, does it make any difference? Do we really need that? Were they thinking they were changing something else, or they couldn't account for where that capacitor was? I don't know. Okay, so this is down, this is off. I'm just going to be careful and just completely disconnect the power. And I'm going to populate all the rest of the tubes. I'll bring you back when I got all those in. Okay, I've got all the tubes in. I contemplated leaving the audio output tube out, but since I've already checked the audio output transformer and all that, I think I'm good to go. So they're all in place. I didn't put the tensioners on there yet because, as I mentioned, we may be changing these tubes out anyway. So I just left them out. Okay. Get this underway, make sure I don't cross any wires, and then we'll be ready to go. Tell you what, since I've got them all hooked up, I think what I'm going to do is go ahead and plug in the antenna and maybe hook up a speaker. So let me go ahead and do that because I might start getting reception. So let me do that. Okay, so we got all the tubes in. You got it uprighted. I've got this hooked back up to the cathode of the rectifier tube again, so that we'll be able to see what the load is with, what the voltage is with all the load on it. And we'll just see what we get. This will be the first time I've used the filament circuit, so it'll be interesting to see how that works. I'm going to come up as slow as I can here, and we'll just see how it works out. So here is, once again, is our amperage, and I do have a bulb light back here. I do have another dim bulb up there I may have to bypass, because I'm going to expect to get probably about 5 amps out of this and probably have too much voltage drop. I don't need 2 dim bulbs. Okay, that one up there is really just kind of protecting this in case that one's... I'm comfortable with this now. Okay, so let's see. This switch is on. I have a little speaker set here, just used for test purposes. So I have a 4 ohm load on there, and if we get some sound out of there, we'll hear something. I also wanted to hook up an antenna. Bear with me a second. So the antenna is plugged in, and I will hook that up to my shop wire. I've got a wire that hangs from the ceiling. It just gives us a little bit of something. Okay. Got enough things hooked up, don't I? All right, here we go. Turn that all the way down. Voltage in, past the dim bulb. Current, measuring the voltage in DC out of the rectifier with all the filaments in. Okay, let's go for it. Somebody's beeping at me. What's wrong? I think it wants to be reset. Okay. Yep. Set for DC. Okay. Can you see that okay? All right. That's reading millivolts. Okay, here we go. One volt. Okay, we're moving 1 1/4 amps. That's at 1.5 volts. 2 volts. 3 volts, moving 1.5 amps. Should be hearing the vibrator start up soon. There's a vibrator. Here's voltage coming up. Now, we start to see some glow. I see some glow on one of the tubes. Okay, I'm going to kind of take it easy here. We're at 4 volts, 2 amps. We're running 133 volts out of the rectifier cathode, which, as I mentioned, with full load should be about, what does that say, 260 volts. All right. Four and a half volts, 2.5 amps. I can barely see the glow on the bulb in there. I know you can't see it, that's fine. We know it's working. We're almost to 5 volts. 5 volts DC, running 3 amps. 144 volts out. Definitely have a little bit of a glow on the bulb, which is fine. It's in there. You can see a bit of the orange. Okay, let's go on up. Five volts. 5.3 volts, 3.5 amps. I was expecting to have higher voltage than this coming out of the rectifier by now. Okay, I'm up almost the top here. What I'm going to do is turn this down and then bypass the dim bulb, which is glowing. It says I'm pulling 450 milliamps on the AC line, but you can see the voltage here has dropped down to about 95 volts. So what I'm going to do is turn this down a little bit and then bypass the dim bulb on the AC line coming in. Bypassing now. We're 5.35 volts. There we go. Just keep going up. 5.5 volts, 5.6 volts. 5.9, 6 volts, 3.5 amps. This is not high enough. We're getting sound.
Of the oscillators is the Officer Tatum Show. 844-900-7243. That's 844-900-7243. Bring home the win like specs. The fun starts here. Makes his big league debut. Long awaited. Should have happened long ago, but you know what? The Astros are in a spot where they were kind of stuck, not being able to get him onto the roster. Now,
try to go to 6.3 if I can adjust it that closely.
Verlander being out right now helps that be possible. So we'll see how the Astros use him. The plan was originally
6.3 volts, just under 4 amps, getting 188 volts on the cathode, which, as I mentioned, is a little low. That's a little bit low. This is 188 volts instead of 260. That's a little low. It could be because these guys here are leaky. It could be some other reasons here, but I'm thinking that either these two or this one are the primary culprits for that. But meanwhile, hey, we got a radio that works. So I've gone through and I've made some replacements of a couple of resistors in here that were not in accordance to the specification that were in the on the schematics. I think I talked about these, maybe I haven't. So basically these two were not in accordance with the spec. This one, instead of being 330, was 220. That M is 1000 in this old one. Meg will say meg. So this 330K was actually a 220K that was in there. And this one, instead of being a 1 meg, was a 2.2 meg, measured 2 meg. So I've replaced both of these to see what that would do with the voltage that we have. And it didn't really affect the voltage too much, as you can see here. Performance, I think it sounds just as good. So I don't think it made any difference. So then the next thing I got to thinking about, so what could be causing this voltage to be low? When I didn't have any conduction from the tubes, I was able to reach, the higher voltages just fine. Like I say, this is supposed to be about 260 or so. So obviously that means that the difference is moving current. Well, okay, I've got the dim bulb over here, which is of course reducing current, but I've been measuring the voltage, on the other side of the dim bulb. So what I'm going to do though is I think I'm pretty careful now. I'm being pretty cautious. I've had this playing for a while since I did the change out. I'm happy with the current flow. I'm at 6 volts DC. So I don't think I have any shorts. So what I'm going to do is I'm going to bypass the bulb, and then we'll see what that does in terms of the performance of this, and then see what we get. So let me get that bypassed temporarily. I'm just using a jumper to cross between the two leads, terminals. So this should cause a drop in, actually an increase, right? Let me reduce this. Okay. Put that on. You can hear the frequency of the vibrator change. Okay. So now we got the bulb out of the circuit. Go ahead and bring this back up. Okay, and that helped a little bit, but basically what it should have been doing is just providing this to have more headroom. So I got to thinking about, well, what else could be causing the difference in voltage that I'm getting here at the unit based on having 3.5 amps versus very little amps. Well, to me that suggests that really I'm getting more voltage drop due to the resistance of my test leads than I thought. Normally when I'm working on radios, I'm usually working with higher voltages, at least wall voltage, and then I'm up to several hundred volts a lot of times. So I'm not moving a lot of current usually. But in this case we are moving a lot of current for the lead coming into here because we're only at 6 volts. Okay, so this is a naturally large current from what I normally deal with when I'm working on radios. So what I need to do is I'm going to look at changing my voltage tap points to be as close as I can to where the power comes in the radio, so I'm not looking at any of this. So we're currently at 6 volts, 181 at the cathode. Let me change where this is sensing, which was right after the dim bulb, but now that still goes through my panel. It goes through a number of things here. So now what I'm going to do is connect this up as direct as I can to the radio. So I'm going to go right here, which is right as where it comes in. Okay, and this other one I'm going to connect directly to the chassis. Right, so as before we thought we were measuring 6 volts going into the radio. We were actually only at 4.8. So why don't we continue coming up on the voltage and let's see what that does. I'll turn this up a little bit so we can hear it. Okay, we're going to go to 6. Current's coming up. Voltage is coming up over here. Okay. There we go. 6 volts in. We're moving 4 3/4 amps. And look here. Now we're getting into range. 236. The goal was 260. Yeah, 260 volts is nominal, and usually with these things you can go 10% off. So 10% off of that would be 234. Well, we're already above that point. I've still got some other resistors that we can change, but as you can see, that made a big difference in terms of the voltage out of the cathode. So that's made a big difference. So we're definitely within the range of good performance right now. So I'm going to look at changing these other resistors in here that look like they might be off. I'll double check them again. But it looks like we're moving along pretty good here. Next thing to do will probably be to decide what to do about this. I'll test with and without this to see if it was necessary for real. And then we'll look at changing out the electrolytics that are in here. There's 3. one on either side of this power resistor, and another one that's right past the plate on the audio output tube. I've got replacements for those. They're nice Nichicon, and we'll put those in. Like I said, I don't know whether or not we need this or not. We might try just disconnecting it and see how that affects things, but I'll do that much later. I also did a check of the IF on this to see if it seems to be tuned pretty good. Now these are supposed to be at 262 or 262.5 kilohertz for the IF. It's different from regular AM radios or like 455 because it was too close to the frequency of the sparks going off in the ignition system. So for radios, in cars, they change it to 262. Anyway, I did a check on that, and it looked like to me that this thing has been peaked. I'm going to double check my meter to make sure, double check my frequency counter. I just did a quick check on it, and it looks like to me that it was tuned to 264.4, which is pretty, close. I might be able to line that just a little bit closer, but we'll see if we get around to that point. Anyway, so I'm going to go in here and continue to work on the resistors, but we're definitely in the ballpark now, and I'm happy the way this thing is operating. It's playing pretty well. Okay, so I went back through and I checked some of the other resistors that are in here. In a lot of cases, what happened was I would pull and loosen like one lead and then check it with one leg pulled. And many of them that I had thought were not within tolerance are actually just fine. This one up here is fine. The others you saw that marked with yellow tape were fine. There was one in particular, I think I pointed out, it was over here, that was supposed to be 3900 and was measuring 368. Well, when I raised one leg on that, it was measuring 3900 because, as you can see, it's actually in parallel with this 390. So once I got that leg lifted, it was fine. Okay, so the other thing that's been kind of fun is, okay, remember I was talking about these two resistors here. This one here, it says it's calling for a 330 K resistor and it had a 220 in it. This one here is calling for a 1 meg. It had a 2.2 meg in it. This schematic is, I believe, from a 1953 bulletin for this radio. And if you look in the SAMs, it'll say the same thing. And keep note, this one has the cathode at 260 volts. Okay, but I mentioned earlier that I had a shop manual that was made for this, and it was 54. And yes, indeed, instead of 330, it shows a 220 and a 2.2 meg here on the AVC line. So yeah, I'm going to go ahead and I'm going to switch these back so that they're back as they're supposed to be in accordance with the schematic, because it was at one time correct. Other thing that's kind of interesting to notice is that on here, the cathode voltage there looks like it says, does that say 260 or 250? I can't tell. Can you tell? I'm looking at it on the television screen. It's best I've been able to see it. It looks like 260, doesn't it? It could be 250. That's a 5. Anyway, but we'll check. And here it mentions the tolerance of the voltage as being plus or minus 10%. Okay, so what I'm going to do is I'm going to go ahead and get this one and this one changed back to 220K and 2.2 meg on this one here. The other thing I've been doing is trying to figure out how I'm going to put in the replacement filter capacitors. I've got a couple here, and I've made a mock-up of a way to attach them to a barrier strip here, a terminal strip, and trying to figure out how am I going to fit these in here. So this is a triple zone capacitor, a 3-part. It's got 2 that are high voltage. That's one here and one here. This is the ground over here. And then this one is a fairly low voltage, relatively speaking, that comes off the plate, past the capacitor coming from the plate. So I may take a low value one for this and wire it up over here on this side. and then move some of these guys around. And I think that'll create some space. I think what I'm going to try to look at doing is leaving the old capacitor there. I'll disconnect the leads going to it. This one here goes to the audio output transformer. There's another one down here below that comes over here. And then there's another one here that goes over towards the that other coming past this capacitor, coming from the plate of the audio output tube. Anyway, what I was thinking about doing is that maybe using that lead right there on the capacitor to make an anchor point and attaching this in there. So I'd get this out of the way, bring it over here, I'll bring some of the wires back, get this maybe up and out of the way, and then see about bringing this right in here, and then that power resistor will go from here to here. Those two leads will not be connected. I'll get them out of the way. And maybe just to keep things clean, I may even run a jumper from this old positive post from this capacitor straight to the ground here, just so that there's no way anything could be going on in there, but I don't think it's going to happen anyway. Anyway, I'm going to take a look at doing all of that, but first thing I'm going to do is get this back on here, check the voltage, make sure it's all okay. I'm going to get in here and clean some of this off and do a last check before I go in and start doing the filter caps. Okay, so we got the wires disconnected from the three-part electrolytic that's here. This comes from the cathode, this goes to the audio output transformer. They both go connected here. Then there's this 1800 that jumps from here to here. This one, it gets this lead that comes over here to pin 1, 2, 3, 4 on the audio output tube. And then the lead here, and also the orange drop, which is here, runs over to here. And the orange drop, 1600 volts. That's good to see. All right, I'm going to reuse this. So now what we want to do is see if we can get those electrolytics to fit, and if I can attach it to here. Let's see if I can get it to work. Okay, so we got the a minute ago I mentioned the resistors. Okay, so we've got the electrolytic capacitor out of the circuit. I'll show you what happened with those leads in just a minute. Here is the two high voltage capacitor sections, and they're in there really solid. And then the other lower voltage one is now here. So where that orange drop was over here, I've now reversed it. It's over here on this side, and then the low voltage capacitor 19A is here in parallel with this resistor here. Okay, and so the way this is mounted is we had three leads coming off of the electrolytic. Two of the three I've bent down out of the way. Let's see if you can see that in there. So I've bent this one and this one just down out of the way. The third one I've used as a mounting point for the lug strip. I've got a number 6 stainless steel screw in through here with a star washer and a dab of blue Loctite on that. So that is solid. That's really not going anywhere. This is the power resistor. It goes between the two caps, the intermodal one, and then here are the two electrolytics. Now the negative lead here, even though it does also kind of come over here to this lead of the old capacitor, I've also got a ground lead that goes directly from here to the chassis down here, which is where these other leads go. So there's no way that that's going to do anything. Basically it shorts out that leg, and these other two aren't connected to anything. Okay, I think what we'll do is put this on the dim bulb and bring it up to voltage and see if it works okay. Okay, we've got the dim bulb is in the circuit, amps, volts. These are inoperable, and we'll be measuring the cathode voltage DC here. Okay, I think we're ready to go. Switch is on. Power is into the DC power supply. We'll bring on the voltage. Watch the DC voltage come up here. Okay, that's millivolts. Here we go. You see that? Okay, 1.5 volts. We're already up pretty high here. I noticed that the vibrator started up earlier. Moving 2 amps.
Astros manager Dusty Baker after the win tonight. He talked about getting Lance McCullers there deep into the start. He was fantastic, picks up his 4th win of the season. Here's what the Astros starter had to say about his successful night. Offense picking up there.
Okay, so we're at 5.3 volts DC, moving 4 amps. Got a good glow on the bulb, but kind of peaked out here. So what I want to do is let it sit here for just a bit, and then I'll bypass the bulb, and we'll see how it gets when we go all the way up to full 6 volts, and we can measure the voltage then on the cathode. But currently we're at 200 volts. Okay, I'm going to bypass the bulb and turn the voltage down. Let's bring it on up.
That was Lance McCullers after his win tonight in his hometown, going up there down, and yes, the Astros sweeping that series, something they had never done over there in Tampa. Pretty cool moment for them. Final guy to hear from is the other Tampa native, Kyle Tucker. Hit a big old massive blast off of former Astro Brooks Raley. Here's what he had to say about his great night.
So we'll let it stabilize, but we're at about 6 volts. It's moving around some as the tubes are starting to conduct at different rates. But we're supposed to be 250, we're now at 240. I mean, that's really, really good. Somewhere between, 225 and 275 is a plus or minus 10%. So we're in good shape there. Okay, I'm going to let it play for a while, and then we'll come back and see how it's doing. Okay, it's about 10 minutes later. We've got it stabilized around 6 volts. The plate is back at 235, somewhere around there. And, not the plate, but the cathode of the rectifier. Alright, so what we're going to do is just test a few voltages, see if it makes sense. So it says go to no signal. Okay, no signal. I'm going to pull the antenna to just make sure there's no signal. Okay. Now I'm going to turn the volume to max. And that's the condition you're supposed to be measuring at. That's 6 volts over here. Okay. This isn't regulated. Okay. 6 volts, moving almost 5 amps. Okay, so the cathode of the rectifier is 230. It's supposed to be 250, so that's fine. We can just test a few more real quick. The plate of the audio output tube, 235. Let's see, the plate is here. I think 222, that's fine. It's within 10%. The screen is supposed to be 205. It's 190. Okay, sounds good. We're going to check to see how much DC we're getting past the coupling capacitor from the detector first audio, this guy right here. And we're in millivolts here, and we're switching positive and negative, so because of the way this thing tests, I'm going to say that's okay. Alright, I think we're in pretty good shape. Go back and give it a signal back.
He needs 13 to tie the rest 2 to get past.
Okay, I'm going to keep letting it play for a while and we'll see how it does. Okay guys, I think I'm going to break this part off here. We got a radio that works. We're checking some voltages. They seem to be in pretty good shape, pretty close. Got a few more things to tackle next, so we'll get into that in the next part. So listen, I appreciate you guys watching. Thanks for the kind comments. I'll see you in part 3. Thanks. Bye.